Hello, welcome to lecture 3 of my 16 to 18 mathematics series. Hopefully you've enjoyed the first 2 lectures. If not, go back and watch them. They're not prerequisites for this lecture, which is on quadratic functions. So let's have a look at the quadratic form. So the quadratic form, the quadratic equation, is f of x, which is some function of x, is equal to a, which is a real constant, times x squared, plus bx, and b is a real constant, plus c, where c is a constant. The highest order, the highest degree is 2, is the highest order power is 2, and this what makes it a quadratic. Okay, you can have b equals 0, you can even have c equals 0, however a cannot be 0, otherwise it's no longer a quadratic equation. Now you'll often see f of x replaced with y, so for example y equals ax squared plus bx plus c. That's also the quadratic form. So what we're going to do is we're going to look at the function itself, what it looks like when you sketch it, and what some of these coefficients mean. So here's the first case. Here's what a quadratic function generally looks like. Okay, what we can see is that it's not a straight line, it's a curve. It's actually called a parabola. Okay, you can see as x increases it kind of shoots off, because as the number gets bigger, if we square it we increase faster than a linear equation. So what shape can we have then? We can have this U-shaped parabola or a N-shaped parabola. The shape of the parabola overall is given by the value of a. If a is bigger than 0, a positive number, we get the U shape. And if it's less than 0, we get this N shape. Yep. Now, in this, we'll go into this later, but in these graphs, I've drawn it crossing the x-axis. Yep. It doesn't always have to do that, okay? But here are some things a quadratic does have to do. It can only have one turning point, yep, one stationary point. It can't go up and then down then up. It can only go down then up, or up and then down. Yeah. Okay. But generally the shape is given by the value of a. If we look at the value of c in this equation, let's really think about what it means. In the linear equation, when you have y equals mx plus c, c is the intersection with the y-axis, and in the quadratic equation, it's exactly the same thing. On the y-axis, the y-axis is the point where x equals 0, isn't it? Here, along this, x equals 0. If I put x equals 0 into my equation, I get f of x, or y, equals 0 plus 0 plus c. So when x is 0, y equals c. And this point here, where it intercepts, has the coordinates of 0, c. So, for example, if I have a graph y equals x squared plus 6x plus 7, I can instantly say the intercept will be at the point 0, 7. Okay? And that actually makes sketching things quite easy. So, let's look at the final case. Again, I've been sketching curves where we cross the x-axis and then come back above it. However, this isn't necessarily always the case. There's 3 different cases you can get with quadratic curves. Here's the case we've been sketching, where we cross the x-axis in 2 different places. Okay, wherever the quadratic graph crosses the x-axis, this is called a root. Yeah. So everywhere you see a little red dot, that's a root of the equation, yeah? At these points, y equals to 0, yeah? On the x-axis, y is 0, isn't it? You think about y equals -2, -1, 0, 1, 2. The x-axis is where y equals 0, and wherever the quadratic equation crosses the x-axis is a root. Okay, so you can have 2 real and distinct roots. You can have 1 repeated root. Now, I haven't, because of my bad drawing, you can't really see this, but it just touches the x-axis. Yep. Really, this should be here. It just touches it, and it touches it in one place. You have a repeated root, okay? And the final case is where we have no real roots. It doesn't cross the x-axis at all. And this is the no real roots case. So here, and there's also, here we've really kind of covered the main points for sketching curves, yeah? We've covered the value of A and the value of C, yeah, and the roots. Now in future lectures we'll go to discover how we can calculate the roots, and also just quickly knowing how many roots there will be. We'll also in future lectures work out how to locate the minimum or maximum point. Yep. You can use these coefficients to work out where your curve turns around. Okay, and this is known as a stationary point, or a maximum or minimum point. Sorry, I shouldn't put that red dot there. That's confusing. So let's look at some examples then. We're going to sketch these all on the same curve. Okay, so y equals x squared. Well, in this form, a is 1, b is 0, and c is 0. So what do we think happens then? Well, c is 0, so it's going to intercept here. Sorry, this should be in black. A is greater than 0 because it's 1, so it's going to do something like this. Okay, in this case, we have 1 root. Now, there's a way to calculate that, but we can see we have this 1 root. Okay, of the graph y equals x squared plus 2. Again, a is 1, so it's greater than 0, giving us a U shape, and c is 2. So our graph is going to do something like this. Okay. With the second graph, y equals 2 minus x squared, well, the intercept is again 2, so it's going to cross here, but the coefficient of x squared is minus 1. If it's a negative term, it's less than 0. So it's going to do something like this. Okay, so that's basically what you need to know about sketching so far. In future lectures we'll work out ways to calculate these roots, knowing how many roots there are, and then how to calculate them. But this basically gives you an indication of what a quadratic function is. Yeah, something like this. Okay. Thanks for watching, guys. This is basically an introduction to quadratics, and the next lecture will be